computer. I'm gonna record this part so you can watch it later if you want to study or whatever. So
Okay.
this is the emulator. It's not gonna look exactly the same, but your screens should be similar. If you want to change from degree to radian, find the mode key. Let me get my spotlight going because I'm not sharing my screen here. So am I? Probably not.
No.
Let me make sure that I'm sharing the screen. There we go. All right, so now find the, okay, Shauna, you're sharing the screen. Now let's annotate your screen. Spotlight, there we are. All right, so here, find the mode key. Click the mode key.
Oh, okay. So
And
click the
and you
okay.
should see
Click.
a screen that's similar to this.
Okay.
Okay.
Yes.
If you want to change from radian to degree mode, you go down to where whatever line that's on. For me, it's the third line. Okay.
Okay.
Arrow over, use your arrow keys and go to degree and then hit enter until you see, notice that the background changes. You see that?
Uh-huh.
And then if you want to see if it really took effect, scroll down, degrees should be highlighted. Now,
Okay.
that means I'm in degree mode. If you want to be in radian mode, you can go back up here, highlight radian, and go back
Okay.
and do that. Whatever mode you're in, you can switch back and forth between them. You can still do the pi over 180 thing if you want, but this just means that if you have it in a certain mode, that if you put in like 45 cosine, it's going to think that you're in 45 radians, which is pi over, like, that's pi over 4, as,
Okay.
you know what I mean? But
Yeah.
if you enter 45 and it's in degrees, it's going to take it as 45 degrees, you see?
Okay.
So if you're in radians, you want to enter like pi over 4 for 45
Okay.
degrees. If you're in degree mode, you want to enter 45. You see what I'm saying?
Okay. Yeah. Yeah. Yeah.
But that's how you change that. If you want to change the number of decimal places that you see, you can change that by changing the float and specifying the number of decimal places. It will automatically show you a certain number of decimal places after the decimal, but most people prefer to keep it on floating.
Okay. Perfect. Thank you, Shauna.
You're
I was
welcome.
trying to figure out that one. Also, I have a random question. Can you do
Yes.
absolute value on this?
Yes, you can. You
How do
can.
you do that?
So the way you do that, if I wanted to graph it, let's say, right?
Okay.
First, I'm going to fix my window because I have no idea what window because I use this for everything. So I'm going to check my window really quick. Window. Yeah, see, my window's all funky because I was doing some funky stuff. So I'm going to go to standard. So I'm going to go, the easiest way to do that, you can put everything in, or you can go to zoom, which is next to it right here,
Okay.
and go to standard window, which is, for me, is number 6,
Mine too.
depending on how many options you have on yours. Then you get a
120,
standard.
Shauna. 160.
Okay,
Okay.
so here's a standard window. Now we don't see anything because we haven't put anything in yet. If you had something there, you might have seen it. Now the way you enter absolute value, it's hiding, it's on the math menu. So go
Okay.
to the math key, and then you see how you have a bunch of menus up here, like sub menus up
Yeah.
here? Go to the one that says NUM.
Okay.
Go to NUM, which is
Uh-huh.
number, and the first option on your list says ABS.
Okay.
That's absolute value. Click that, and there's your absolute value bars.
Whoa. Okay.
So if I wanted to put in let's just do something, whoops, let's just do something easy like the absolute value of X. Since we know what that looks like. There it is, all right?
Okay.
There's the absolute value of X. And make sure you arrow in. On my calculator, you have to arrow over so it looks complete. If it looks kind of funky like this, like it has an extra space, just arrow over so that it looks. Now, if you hit graph, there it is.
Okay. Pretty cool. Good to know. Thank
Okay.
you, Shauna.
So if I wanted to graph something like, if I go back, I'm going to hit Y equals here. And if I wanted to edit this, I'll just backspace and we'll do it again for practice. So remember, it's on the math menu. So math, then arrow over to num, then hit either enter or the number 1 for absolute value. Let's say I wanted to enter something. Now let's say I had the absolute value of a fraction. Then I need a parenthesis and I could do X. I could do something like X plus 1. And then I could do X plus 1 divided by X, for example, right? Now this would be a single absolute value. This is X plus 1 over X, okay? This is not two absolute values by itself, but if I graph this one, it looks like this. Now, this looks a little
Whoa.
funky because there's going to be a discontinuity right here.
Okay.
How do I know that? Because at 0, and this is where sometimes with absolute values, you have to be a little smarter than your calculator. How did I know that? Because at 0, this is undefined, right?
Uh-huh.
So what the calculator is attempting to do is hook these together, but they're really not supposed to be hooked together, all right? But if I did this, let me show you this question. If I wanted to do something like this, you could also do X plus 1, right? That's absolute value of X plus 1. What if I wanted to divide by another absolute value? Well, then you hit the division sign. You go to math here. You go to num here. And then you repeat it. You divide by the absolute value, let's say, of X. Now, this is going to be somewhat familiar to you, I hope, because this is one of the graphs we did yesterday. It doesn't show up quite as nicely in this mode. It looks very similar, okay? Because, again, it's trying to connect it when it's not connected, okay? So what you can do, you can either use your detective skills, okay, for algebra. But one thing you can do is for a situation like that, if you go back to mode here, and you see how down here further on your list, you should have something that says connected versus dot. You see that?
Yeah. Where? What was it? Was it?
It should be connected versus dot. You should have a connected option versus a dot option.
What button do I click again?
What was that?
What
Mode.
button do I click again?
Go
Mode.
to mode. Mode key.
There. I see radian, function, thick, sequential, real, and full. I don't see it connected.
Okay, so maybe it doesn't. I'm not sure if I'll have to look it up, but if you're in that situation where you can do it in a dot mode, let me show you this.
Well, there's thick, and then right next to it is dot thick.
Well, here's the situation. If you look at it as dots, look what happens here. The nice thing about this is it shows you that there's no dot at 0. Like it's coming up here, doing this, and then it's coming back down. It's broken at 0, which you would expect because there should be a hole there, right? So it's a little bit less. The calculator sometimes with more complex absolute value graphs can get a little funky with stuff. Okay, so just something to be aware of when you're doing it. All right.
Okay.
So that's how you graph absolute value. Now let's go back to your homework here. Let's go back to your homework because I want to show you that. And we'll do some homework. Limit as x approaches -2 of 3 to the x plus 4 minus 2. Okay. So now, here was what I'm going to do. I'm going to enter, I'm going to go to your calculator here. I'm going to get rid of this graph. And I'm going to enter it. So now, the way I'm going to do this is I'm going to put 3 in there. And I want to go to the power. So I'm going to hit the little caret thing that looks like a triangle under the clear button right here. And then I'm going to go X. This is going to be X plus 4. And I want that whole thing to be part of the exponent. Okay. Then I'm going to go down and it's going to be -2. So it should look like this. Okay. Now, if your calculator doesn't show this as an exponent, okay, you might have to, depending on what you're seeing, you might have to do 3 and then your caret symbol, which is the triangle, okay? And you might have to use, depending on what your calculator behavior is, you might have to use parentheses here for the exponent. X plus 4 minus 2. Okay. Now I'm going to go ahead and graph this and see what happens. If I graph in a standard window, let me see what happens with this. Okay, so that's my graph. All right.
Okay.
This is my graph. Let me show you on, but that's, I wanted to specifically show you on the calculator because that's what you're using here. Now, let me show you here. I'm going to go to,
Is the 2 part of the exponent or is it down?
no, it's separate. The x plus 4 is part of the exponent.
Okay.
The 2 is separate. So this is, I'm going to come down here. This is going to be, okay. I'm going to pull up Desmos because Desmos is a bigger picture of the same curve. It's just easier to annotate on. I'm gonna have to use x plus 4. And just a clue for you, on Desmos, you have to use parentheses if the exponent contains more than one term. So here's a picture of, let me do a new share. Let me do your Desmos screen here. This is what this graph looks like. Okay. Now, okay, so here I am, right? And I'm approaching negative, -2, it said.
Hmm.
Let me remember what the actual homework was telling us, because I don't have that in front of me right now. So let me go to my I'm gonna go to my downloads and look at my homework and see what I think I downloaded it. So in this case,
What problem are you looking at, Shauna?
this is problem 1 of what you sent me.
Who did I send you? Because when she get, hold on. Oh my goodness.
The limits of transcendental function.
That's different than what she gave. I don't know. Yeah. Which side is this? I'm gonna assume that this is what we're doing. Cause
I'm looking at this, Hannah.
yeah, I know what you're. Yeah, I'm seeing it too. Hold on. Cause I was gonna say that looks like. Did I send you the? I sent you the wrong one. I'm so sorry, Shauna.
No
Oh my
worries.
goodness. I sent you last night. One a part of last night's homework. I was gonna say that's look really familiar.
No worries.
Oops.
But at least we learned how to use the calculator now.
Yeah, I appreciate that. Cause oh my goodness. I did not realize like the calculator is its own thing. It's
Yes, it
like
is. That is very true. That
it
is
is its
very
own
true.
learning curve.
Yes, I agree.
Okay, this is the one.
Part. Now, this is something that I do when I teach it, and it helps a lot of students. It's not to insult your intelligence in any way.
Okay,
It just helps you think about, so this is the left and this is the right. Okay? I know you know that. That's not what this is about. This is about helping you not to have to think about that when you're doing it. So number 1A says, find the limit as x approaches -1, and it has a little mark after it. The mark after it tells you which side you're approaching from. -1
okay,
from the left. So first, find whatever this number is, find it on the x-axis. So that's this point right here, okay? I'm
right.
gonna mark it. I wouldn't suggest that you mark every single, I'm just gonna do it for the sake of clarity. I'm gonna mark below it though, so we don't get confused with the graph itself, because this has got a lot of little dots and holes and stuff on it. So I'm gonna mark it there. -1. Now, what I wanna do is I wanna approach -1 from the left, So what this means is here is the left, and I'm approaching this -1 from the left. So remember, the answer is a y number. So start tracing the graph. You're going to -1, okay? This is -2. That's not far enough. So you're approaching -1, okay? Looks pretty good, right? What do we have
Right.
here? Where are we?
It'll be 0.
0. Right.
Okay.
So the limit as x approaches -1 from the left of f of x is 0. Now we're going to
Okay.
do the same thing, but we're going to approach from the right. Okay?
Right.
From the
Okay.
right. Now, let me show you. You have to start from here. Now, we're not anywhere near -1. I just want to show you something. So you would trace it, skip over the hole, keep going, right? Skip, here you get to this defined point, jump this continuity right here. Here we are, this is 0, right? We're approaching 0, so we're not at -1 yet. Jump down here, okay, we're getting warmer, right? And it looks like it's continuous at -1 because guess what? What is it?
It's 0.
0, right. It's continuous at -1, so we don't have a problem here, right? So this limit, now see, the limit as x approaches -1 of f of x, because these limits in A and B match each other, this limit exists and it's
0.
0. Okay? Number 2, we're going to 0 now. What is this telling us in number 2? I'm going to erase my green mark under -1.
Okay.
What is number 2a telling us?
All right. You're approaching from the left side to 0.
Yeah, you're approaching 0 from the left. 0 is going to be basically the origin.
Right.
Okay? Remember, your answer to the limit is going to be a y number, a y-axis number.
Okay.
So the limit, I'm going to spotlight this. So the limit as x approaches 0 from the left. So again, okay, getting close to 0, right? Where am
It'll
I?
be -1.
-1, right.
Okay.
So if I'm approaching from the left, it's -1. Now, if I'm approaching from the right, then I'm going over here. Skip that. Now, I'm approaching 0. Here I am at 0, right? Because I'm on the x-axis. I'm at 0, correct?
Right.
But where is my y here?
3.
It's at 3. You see that?
Yes.
You see the difference? Even though it has a hole there, it doesn't have to be defined for the limit to exist.
Okay.
Okay? So it doesn't have to be defined as this. It's actually defined as -1, but the limit here is not that. The limit here is 3, isn't it?
Right.
Okay. Now these limits in number 2 don't match, do they?
No, so it doesn't exist.
So this limit in C doesn't exist, right?
Okay.
Because this function, when we'll get to this later, this function is discontinuous at 0, isn't it?
Right.
And we can
It
see
doesn't
that.
jump, right?
We can see that by looking at it, right? It's
Okay.
discontinuous at 0. All right, let's do number 3 now. Limit
Okay.
as x approaches. What is number 3 saying?
Okay. Limit f of x as x approaches 2 from the left side.
2 from the, now don't confuse that with -2.
Okay.
Okay, that's not what this says. It says 2, which is over here. So we're approaching 2 right here. We're approaching 2 from the left. So what it means is we're going and then we're approaching 2. Now here we are at 2. From the left, what are we getting close to?
3.
Yes. Even though it has a hole right here, that limit is 3, isn't it?
Right.
What is the limit as x approaches 2 from the right?
It's gonna be 1.
Correct.
Okay, so that means that it's discontinuous.
It's discontinuous at 2. That's correct. And so the limit as x approaches 2 of f of x, this limit doesn't exist either, does it?
No.
Good job. Number 4.
Okay.
Number 4. Take
So it
your
says,
time.
okay. So it
Am I
says,
rushing you?
no, I feel good.
Okay. How about number 4?
All right. Limit f of x as x approaches -2 from the left side.
Okay, -2. So we're over here now. -2 from the left. So,
Okay. So that'll be 1.
yes, good
Okay.
job.
Feel good.
How about the right?
So coming from the right, that'll be 1.
It's also 1. Right.
Okay. So then
Now
that
this
means that
is,
it's
uh-huh.
so then that means that it's not discontinuous, so it's 1, right?
Okay, now the limit exists and it's equal to 1. So the answer to C would be 1. That's true.
Okay.
Okay. But remember, there's another condition for continuity.
Oh, f of x, right? F of
So
x has to exist.
technically, right. So technically the limit exists, okay?
Okay.
And the function is defined because there it is up there,
Right.
black dot.
But f of
But-
x would be 4, right?
Right, so this is discontinuous, but not
Okay.
because the limit doesn't exist. Right here, they're just asking you about the limits, okay?
Okay.
So be a little bit careful there. But
Okay.
technically, this is discontinuous at -2 because the value of the limit here doesn't match the value of the function at that point.
Got it. Okay.
All right, so
Got it.
very good though. This is making sense, isn't it?
Yes.
All right, how about number 5?
Okay. Limit f of x as x approaches 4 from the left side.
4 from the left. If you need me to draw, I can.
Okay.
4 is over here. 4 from the left. What do you think the limit is there?
1.
Yes.
Okay. Okay. Ooh. Okay. And then from the right side, it is also 1.
It's also 1. Very good.
And so that means that the limit is 1.
The limit is 1. Now, does that
Okay.
mean that it's continuous?
No.
Not necessarily. Could be, but it's not necessarily true. Is it continuous at 4 here?
No.
Why not?
Because it's an open circle, so that
Right,
means that the f of x isn't defined.
Beautiful. Ta-da! Okay.
Oh.
Good
All right.
job. Good job. Number 6. Okay, now this time they're going to ask you about continuity. Be a little bit careful because the questions they're asking are a little bit different. Okay.
Okay.
Number
so
6. Try it.
So limit f of x as x approaches -1 from both sides. Right?
Right.
that would
This
be
means that my limit, so I have to look at -1. And remember, they helped you out because look at problem 1.
oh, cool.
You already know what the limits are, right?
Right.
Now,
Which is
if
0.
they hadn't done that, okay, then you would have to look, since it's asking you about the two-sided limit, you would have to look at this limit at negative, what is it? -1, -1, which is right here, right? You'd have to look at it from both sides. But you already did that in number 1 up here. And what was that limit?
That was 0.
0, right? So now what is f of -1?
It's 0, right?
Correct. So what does that mean?
That it's continuous.
Yes, because the the one-sided limits are equal, so the limit exists, right?
Right.
And it's equal to the value of the function at that point.
Got it.
Yeah?
Okay. Yeah.
How about number 7?
Number 7. So that's as x approaches -2 from both sides.
Okay, look at number 3 problem. You did that already.
Right. So the limit was 1, but f of 2 was 4.
Yes,
So that means it's not continuous.
very good. Because why?
Because what's it called again? The f of x, what's the
The
word
value,
for it?
okay, so this is how you say it. Because the
Okay.
value of the limit, which is what?
It was 1.
1. Because the value of the limit is not equal to the value of the function, which is 4.
Value of the function. Got it. Okay.
Okay,
Okay.
good job. How about number 8?
Okay. Limit f of x as x approaches 0.
Okay, we did that one too.
Right.
Look
And we
at
said that
number 2.
the limit did not exist. Right?
The limit doesn't exist, correct?
So then
But does f of 0 exist?
yes, it exists at -1.
It's equal to, it's equal, it not only exists, it's equal to -1.
Equal
Good
to
job.
-1. Okay.
So
But
is
it means
f,
that it's not continuous. I mean, it
it's
is,
not,
yeah, not
it's
continuous.
good, you're doing great. Is it, now why is it not continuous?
Because the limit of the equation does not equal the value of the equation. Something like
That
that?
essentially that's true, but
Something
the
like that?
limit doesn't even exist here,
Okay,
right?
okay,
So it's
right.
not a matter of they're different. It's I would say
Limit doesn't.
because the limit doesn't exist in the first place.
Okay,
If the
okay,
limit doesn't exist, then we can't talk about it being equal to something else, right?
right.
So it's not, it fails for both of those reasons.
Okay,
Honest. Okay.
okay.
Good job. How about number, what are we on? Number 9?
9.
Okay.
We're
What
at
are we
9.
doing with number 9 here?
Limit f of x as x approaches 2.
Okay, we haven't done this one before.
Nope.
Oh, yes, we did. I lied. Number 3.
Oh,
Number
okay.
3, we did it. Limit as x
Okay.
approaches 2. We can look at the graph again. The limit as x approaches 2. What can we say about that?
The limit doesn't exist.
It does not exist, right?
Okay.
But what is f of 2?
It's 1.
Correct.
Okay.
So is f continuous there?
No,
No, it's not.
because it doesn't have a limit.
Because the limit doesn't exist
It's
in the
not.
first place,
Okay.
right? And if you
Okay.
want to add and, the value of the limit is not equal to both of those reasons. Very good.
Okay. Woohoo.
Beautiful. Number 10.
All right. Limit f of x as x approaches 4.
Okay, we did that in problem number 5.
Right. And that was it was 1.
That limit is 1, so that exists. Okay. What is f of
Okay.
4?
It doesn't exist.
F of 4 does not exist. So is this continuous?
No,
No, why not?
because the value of f of x doesn't exist.
Perfect.
Boom.
That's correct.
Very
That was not
good.
hard, right?
No,
That was
I
not hard.
wasn't.
Now, what
Very
we're
nice.
gonna do what you're gonna do in problems 11 through 14, okay, is you're going to classify your discontinuities as removable, jump, or infinite. Okay.
Okay.
So it's probably better to graph these functions
Okay.
and see what they look like. Okay.
Okay.
Now we could do a whole bunch of fancy dancy algebra, but the easiest way is probably to graph them.
Okay.
Okay. So now the question is, do you know how to graph these?
been a while.
Okay, these are piecewise functions. Let me,
Okay.
I need to
I don't know
scribble.
what that means.
Piece,
I know I
okay,
should know what that
so,
means, but
so, so usually when you think about a function, you think about like f of x and it's equal to one rule, like x squared minus one, or 5x plus 2, or something like that, right?
okay.
If it's a piecewise function, they have more than one rule and they have limited inputs, right? So if you look at number 11,
Okay.
your function has two pieces, doesn't it?
Yes.
Your function has two pieces here.
Yeah.
So what you can do, and I'm going to do this on Desmos just because the screen is larger, okay? F of x is equal to, I'm going
Yeah.
to write the
Perfect.
problem first. X squared minus 1 if x is greater than or equal to 1, and it's equal to 4 minus x if x is less than 1, okay? So what I'm going to do here to show you how this works. Now, there is a way to enter piecewise functions on Desmos, okay? But I'm not going to show you that right away. I will probably show you, but I want you to see the function first. Now, I'm going to use the strategy of plotting points so you can see this, okay? So I'm going to write this as two parts. So what I'm going to do first is I'm going to say that this is the function y equals x squared. Now I'm gonna do something here. I'm gonna actually, what I'm gonna do is I'm gonna go and I'm gonna insert, whoops, no, don't want to do that right yet. Let me see what I'm doing here. No, I don't want to leave. I just want to, okay, cancel, new blank. Okay, so what I'm gonna do is I'm gonna say, I'm gonna add a table to this. So I'm gonna add a table first. Now, the reason that I'm adding a table first, I'm gonna put a note below me here that, and I'll show you how to graph this in Desmos as well. Y equals x squared minus 1. So this is gonna be x squared minus 1. Now, what I'm gonna do up here is I'm going to use points that are from those x values. It said that x has to be greater than or equal to 1. So I'm going to choose x values that are greater than or equal to 1. So if I choose 1 here, 1 squared minus 1 is how much?
Wait, 1 squared minus 1 squared?
So
That's
this is my first
0.
rule. This is my first rule, isn't it?
Oh, yeah. Yeah.
And if I choose values, I have to choose values that are 1 or larger, right?
Okay. Yeah.
So if I put a 1 in here, then essentially what I'm doing is this. I'm saying 1 squared minus 1, right?
Right.
And that's equal to
0.
0, right? This is equal to 0. There's my point. There's 1, 0 there, okay?
Okay.
Now, if I plot the point 2, right? What happens at 2? This is 3. Okay, you see where this is going? We're going to get a
Yeah.
point here. Let's do one more. Let's do 3. What happens there?
3 squared is not, it's 8.
8. So what this is showing us is that we have, I'm gonna have to, okay, so there's my, now this looks like a line, but we know this is a parabola, right? This
Right.
is just the right-hand portion of some parabola, right?
Mm-hmm.
Okay, now it says that if x is less than 1, now this is where this gets a little tricky for students. When you're graphing it, I'm going to add another table in here. So I'm going to say, all right, here's my table, right? And I'm going to have to choose values that are less than 1, right? So let's say I choose 0, okay? Now I'm doing 4, now this is for y. This is for y equals, this is 4 minus x. Okay, this is 4 minus x. So now, if I choose 0 here, 4 minus 0 is what?
4 minus 0 is 4. 4
4.
minus 0 is 4.
4. So there's a point at 4 there, right?
Mm-hmm.
Now here's the thing. 1 was defined as this point up here. 1 was defined as 1, 0, right? Which is right here, right? If I put a 1 in the other format, okay, then I'm gonna get 3 here, right?
Right.
If I put a 1 in here. So if I plot the point, 1 and 3, which I can do, that has to be open because that's not, and the reason that I'm doing that is that when I draw this curve, this is going to be my parabola here, right? It's going to be my parabola going this way, but I have a line that starts at this point. It's a line with a negative slope. So I've got a line that goes, I'm going to plot one more point here. So what if I plot the point, let me see. What if I plot the point, say, -1, just to give me some space to, just so I can see where what if I plot -1? Well,
That'll
that's
be
gonna,
that'll be 5, right?
5, right? So what I'm looking at here, my piecewise function here is going to be this. Now, I did this by hand, okay? And I did that by hand to show you what this looks like and to show you how to generate the graph on your own, okay? But Desmos will do this for you also. You just have to know how to enter it in there. And I'll show you that. But you can get a graph like this. Now, this is my graph of this function. This is a parabola. This is a line with a negative slope. All right. And so I'm going to label, you have these, I'm going to label this point here. So let me choose the mouse and let me label this. And let me go up here. So this is where your labels are. Oops, no, I don't want to zoom. I want to zoom out. Let me see where I'm at. Let me not. There we go. There's my points. Okay. So these are my, so this is where this is. Now, if I'm looking at, if I go back to the homework, which is over here. Wrong homework. Hold on. That was the false alarm homework that we did. Let me find the homework again. I'm gonna have to do some finagling here. Let me finagle around and make sure that, no, these are both wrong. Okay, where's here? There it is. All right, so we want to classify the discontinuities as removable, jump, or infinite. Well, we don't have an asymptote, right?
Right.
So from what we saw on number 11, first of all, when you're looking at it, let me share the screen. When you're looking at an absolute, a piecewise function like this, always look at where the definition changes, okay? And here the definition changes at 1, right? Those are the places where your potential discontinuities occur, okay? So 1, we don't have an asymptote here, okay? Now I can, if I know enough about the graphs, and if I really think about hard, I can figure out that there shouldn't be an infinite discontinuity here, because I would need an asymptote for that, right?
Okay.
And in order to have an asymptote for that, I would have to have a whole series of x values that are not defined, right?
Right.
But my x is defined, isn't it?
Yes.
1 is defined, right?
Yes.
So if you think about, now, let me come back to something else. If you remember,
Would it be a jump?
it's a jump discontinuity.
Okay.
It's a
Because
jump.
because there's an open circle and then there's an open
From
and then a
what
closed
we had
circle.
seen, it's a jump discontinuity. Right?
Okay.
Now,
Cool.
so that's how I would recommend that you do it.
Okay.
Is these 4, or these 4, I would recommend that you graph them, okay?
Okay.
Either on your calculator or on Desmos or by hand or
Okay.
whatever, okay? And remember here, you're not looking at any limits. You're just trying to classify the type of discontinuity you have, okay? Now, again, I want to show you something because I promised I would show you this. So let me show you here. This is absolute value of x minus 3, and you get -4 here, and we're going for x is not 2, and here x equals 2. So what you can do is, let me show you something here. Again, Desmos is easier to see when it's I'm gonna do Zoom square. Okay, there's my Zoom spacer. Let me go ahead and clear this graph out and share the screen again. I'm gonna show you something here. So if you want to enter piecewise functions, you can actually you can do this on your calculator as well. Desmos is easier to see it, but I'll also show you where it is on your calculator, but decimals is easier to find them. So if you have conditions, then what you should do is enter them as separate. So y equals, this is y equals, and you're going to enter the function just like you normally would. So here I need the absolute value symbol. So I need the little keyboard, right? And I need the little absolute value symbol, which is this thing here. And I'm going to enter x minus 3 in there. Okay. And what it's going to do is it's going to give me this symbol. Okay. And then what you do is, I believe, if I'm not mistaken, you enter the little, the curly braces on your keyboard, which are after the letter P on top, and you enter your conditions. So here, X, and you need the other equality symbols. So we're gonna say, move these up. We're gonna say X is not equal to, so we have to do, now this, what I'm gonna do is I'm gonna change this whole, X is not equal to 2, and it's at, so then, I don't know if they have a not equal, do they? Not sure how they handle that. Okay, let me go ahead and leave it like it is. And what I'm gonna do here, I'm gonna cheat a little bit because they don't have a not equal to symbol. If this was a 2, right? This would be 2 minus 3, which would be -1. So the point 2, 1 right here, I'm gonna label this 2, 1. I'm gonna label this point, but I'm going to make it open. So I'm gonna go here and I'm gonna say, make that open right there. So this is the absolute value function with an open circle at that point, okay? Now the other part of it is the point -4 and 2. So this is -4 and 2. And I'm gonna label that point, right? This has a discontinuity. This has a discontinuity, doesn't it?
Right.
What kind of discontinuity do we have?
Well, it's not a jump and it's not infinite.
It's
A
removable.
removable?
It's removable. Essentially, the way you know that it's removable is, could I fill this hole? I could. All I would have to do is define this. I would have to define this point to be, if I wanted to fill the hole at -4, right? This would be -4 minus 3, right? And I would have to define this point at, I would have to fill it. I would have to fill this point up, right? Because my discontinuity is at 2. So essentially, instead of being the point negative, instead of being 2 and -4, I would have to define this as 2 and 1. I would have to go back and redefine this function to fill this hole.
Okay.
Now, this is not going to let me do that, obviously, but that's why I have the discontinuity that I have, because that's my function. This is -4 and 2. So that is a removable discontinuity there.
Okay.
Okay, there it is. That's a removable discontinuity. You see where we're going?
Yeah.
You see how we're doing it? So,
Yeah.
and you can have more than one discontinuity in your situation. You can have more than one of them.
Okay.
Okay.
Kind of like the example in the first, like 1 to 10 problems.
Yeah, you can have, well, and you can have discontinuities in more than one place.
Okay.
So if you go back and you look at, let's look at your homework here. So if I look at this, let me share the screen again. Okay, go up here, share the screen, share the homework. Okay, now 13, they're asking you about one place. What happens at 1 here? Okay,
Okay.
at 1 from the right, okay, my value is going to be 3 minus 1, which is 2, right? And my value from the left is going to be 1.
Okay.
Right? So once again, it's not an infinite, it's not an asymptote that I'm given. It's a situation where the limits are not the same. So chances are this is going to be a jump, right? We don't
Okay.
know that, but chances now, if you look at 14, right, there's 3 parts to this function.
Do you think that there's probably a removable?
Probably on 14, my guess is it's removable at some point.
Probably a
But
removable and a jump, maybe?
probably, but you'd have
Okay.
to graph it to find out. Now, this is 13. So this is going to be g of x. This is 3 minus x. And you've got x is greater than or equal to -1. And here you've got x cubed. And x is less than 1. So what you can do, let me show you on your calculator, because hey, your calculator is your friend, right? So,
Except when they tell you you can't have one.
so what I'm going to do here is I'm going to stop sharing this for a second. I'm going to share the screen, move to the calculator here. What we're going to do is 13 has 2 parts, okay? So what I'm going to do is I'm going to say, I'm going to make sure I have a decent window, which I think I still do. Yeah, we do. We should be okay. I'm going to go to y equals here. And what I'm going to do is I'm going to put in the first part of the function, which is 3 minus x. Okay, 3 minus x. I'm punching it in from the keyboard instead of the numbers, and I have to remember that I can't do that. 3 minus x is my function, right? But I have a restriction on my numbers. So what I'm going to do here, this is something cool. Let me see if I remember how to do this. It's been a minute, okay? So what I'm going to do is I'm going to open a parenthesis here. And I'm going to go and I'm going to say x. I'm going to go to x, right? And I'm going to go to math menu. No, I'm not. I need to find something that says test. So I'm looking for test and I have to see where that's at. Math and tests is going to be the test menu is test is going to be should be there somewhere. I have to find it. There it is. It's on top of, okay, I didn't lie totally. It's on top of the math key. You see it?
Oh, okay. Yeah.
So I'm going to go second math and I'm going to get this menu here. See that? There's all your symbols right there.
That is so cool.
So X is greater. Now I'm going to use greater than or equal to, which is number 4. I'm going to hit number 4 right here. And I want it to be -1. Be sure to use the toggle minus down here and close your parenthesis. Now graph that. And what they've given you is 3 minus X, but graphed as X is less than, greater, I'm sorry, it should have been, yeah, greater than -1. You see that?
Uh-huh.
Now, the other part of this is X cubed. Now, did I happen to, maybe I miscopied something. Hold on, because I've got something on my paper different from the,
You want me to look?
give me a second.
Oh, it's not -1, it's 1,
It's
Shauna.
1, yeah, that's a problem. Let me fix it. That's fine, we can do that. Give me a second. Yeah. Hey, SB. Hey, SB, are you here? Okay, I think Kelly's in the shower right now. Hannah, give me 2 minutes, okay? I'll be right back.
Yeah, no problem, Shauna.
I'm in the middle of a tutoring session, but because I'm wrapping it up with Hannah right now. I'll try, I don't know who's here, I'll try to send somebody out. No, they're, because behaviorists and a whole bunch of other people are here, so, just park where you can find the park, because there's extra people here, that wouldn't own these. And they're, well, no, it's Diana's mom. Diana's mom is here also. Yeah, Diana's mom is here. Let me, yeah, just fine. Julie, I'm not, but SB is outside. Racing. And SB is outside, the family bracelet. You can't come here. It's looking for a place to park. I was sending Julia, she has a short, curly hair, curly black hair, little slight looking woman inside. But circle around, see if you can, but yeah, Diana's mom is here and then some other people are here, that's why. But see if you can, because I think Kelly would like to see you. I think she just got out of the shower. I'll be out in a few minutes. I gotta wrap up this session with Hannah really quick, okay? So just introduce yourself, take your temperature and do all that. And I'll be out in a few minutes, okay? Yeah, I would because we've been exposed recently, so I would have. All right, I'll see you in a few minutes, SB, okay? Sorry about that, Hannah. I've got a few things going on at the moment.
Oh, don't even worry about it, Shauna. I just appreciate you squeezing me in.
No worries. I mean, there was plenty of time. It's just I have stuff going on that wouldn't normally be going on right now. But I wanna show you this so you'll be able to do it. Because I
Okay.
have to show you this and then I think you can probably do 15 and 16, but I want to give you a little bit of guidance on that before I let you go. So here's how this looks. This is 1. So what we're gonna do is we're gonna go back to the calculator here. We're gonna stop screen share. This is negative. This is 1 here. So I'm gonna fix this. Okay, move it away from there. You move away from your little error message and I'll be happy. I'm just gonna delete this negative. There we go. graph it. There we are. Okay, there's that. So it shows you that. Now, the other piece of this, is x cubed when x is less than 1. So here you have your x cubed. So you're going to put x cubed in this function here. X cubed. Oops. I always do that. Let's see. I have a tendency to enter from the keyboard and forget that I can't do that when I'm on the emulator. X cubed. And then I'm going to say, I'm going to open my parenthesis and say x. And you can also, I think up here, I didn't tell you, but up here, I would probably go ahead and insert, let me do this again. This is 3 minus x. This is parenthesis 3 minus x. When 3 minus x. Close the parent. And then do your test menu. So this is x. Second math key. Oops. Second math key. And this is
Hey, Shauna, why don't we put 3 minus x in parentheses? Is there a reason?
I have a feeling that it's giving you, because of the term, I don't know for sure, but I have a feeling it's giving you a different graph.
Okay.
And I'm honestly not sure why, so I'm checking it to see. One here, okay? And then you graph that and you hit, yeah, there we go. Okay, why does it not like me? Why not? Oh, because it's not done yet. Yeah, you have to put, if this term has more than one, because of what it was doing was it was multiplying the x by this other x. And it was giving you another graph. So you have to put the function in parentheses and then the condition after it. Okay.
Okay.
So I think for x cubed will be okay, but I'll know when I see how the graph looks, because that's only one term.
Okay.
That x cubed is only one term, but it's x here, and it's less than, so second math here, and then you're gonna go less than, which is number 5, and 1 here, and then close. And then if you graph it, there it is. That's what this looks like.
Okay.
Now, what you can see here is that you have, it's not an infinite discontinuity. It's a jump like before.
Okay. That's a funky graph.
Well, because it's got a line and then it's got a curve, right?
Yeah.
So that makes that work.
All right. Wow. Okay.
So that's how you would do that. Now, let me just
this.
give you
That's really
some
cool.
quick guidance on,
Okay.
let me give you some quick, I think you can probably handle number 15 and 16 on your own, but I just want to remind you of something, okay? In problems 15, 16, use the 3-part definition of continuity. What's the 3-part definition of continuity say?
The f value has to be the same as the limit of the
Right, but
function.
the 3-part definition is the first part of this, says f of x exists.
Okay.
The second part says the limit exists.
Right.
Now
Okay.
I'm doing shorthand here. And the third
That's
part
okay.
says f of x or f of c, right, is equal to the limit. Remember?
Okay.
That's the three-part definition. So what we have to show in 1516 is that, first of all, what value are we looking at? It tells you we're looking at pi, all right?
Okay.
So first of all, you have to show that this is defined at pi.
Right.
Is it defined at pi? Look at number 15. Is it defined at pi?
For the first, what do you mean by defined?
All right. If I ask you to
Sorry.
evaluate f of x at pi,
Okay.
right, which branch of the function would I use?
Cosine.
Right, I would use the first part. E to the
Okay.
x times cosine x, right?
Right.
So I'm going to replace x with pi. So I would say,
Okay.
so I would write something like f of pi f of pi equals e to the pi, right?
Right.
Times cosine of pi. Now, big question of the day, what's the cosine of pi?
Um.
Hang on. Yes, SB. I think I locked it. Is it okay? Yes, you can come in. I'm wrapping up Hannah's tutoring session right now. You open it, close it. You can close it, because we're still, if I evaluate it at pi, Hannah,
Isn't it 0?
cosine of pi is -1.
Darn it.
Cosine of pi, you're on the left side of the unit
Okay.
circle, so it's -1. E to the pi, so you'd get e to the pi times -1. So this would be negative e to the pi. All right.
All right.
The point is that that's defined
Okay.
as negative e to the pi, right? That's
Okay.
the value of my function, right?
Okay.
Now what I have to do is now I have to find the limit on either side. So
Got
I'm
it. Okay.
approaching pi. And again, you can put the value in there, okay? If it's
Okay.
continuous. So the tangent, I'm going to help you out here. The tangent of 3 pi over 4, that's pi over 4 in the second quadrant. Okay?
Okay.
That's 135 degrees. Okay.
Okay.
That's going to be, that tangent's going to be -1. Okay. So I
Okay.
can tell you that your limits, you can use direct substitution here. Your limits will match.
Okay.
Okay. Your limits will match. You'll get negative e to the pi power, right? And
Okay.
then because the value of the function matches the value of the limit, that function is going to be continuous at pi.
Okay.
Okay, 15 is going to be continuous for that reason. Okay,
Okay.
16 is easier because
Okay.
it's a function that you're more familiar with.
Okay.
Right.
That's good.
So we went through the first 10.
Right.
We did actually the first 12 and a half problems. So basically you just need 14, 15, and 16.
Sounds good. Thank you.
Okay.
All right.
So,
Thank
but
you,
if you
Shauna.
get stuck, especially on 15 and 16,
Okay.
Give me about, let's see, what time is it now? Give me about an hour or so. And
Okay.
I'll send you pictures of 15 and 16.
Okay. Thank you, Shauna.
So you can see how you should write them out. But you're basically using